So, imagine for a second that you are custom engineering an 800 metric ton steel behemoth.
Right. Just a massive piece of equipment.
Yeah, exactly. And it's designed specifically to handle like explosive chemicals, highly corrosive gases, and just these extreme mind-bending pressures.
That pressure that would crush a submarine.
Exactly. And, if a master tailor messes up the seam on a bespoke suit, it's embarrassing. But if the seam on one of these machines fails in the middle of a massive petrochemical plant, I mean, a city block
The
disappears.
stakes are incredibly high. It's not an exaggeration to say that.
No, not at all. And that brings us to our topic today. Welcome to the deep dive. We are looking at a company called the Anup Engineering Ltd, or ANUP for short.
And we have a massive stack of comprehensive company analysis reports to go through today.
We do. We've got market penetration data, unit economics breakdowns, and some very sobering risk assessments, too.
Yeah, the risk assessments are fascinating.
They really are. So our mission today is to figure out how a manufacturer of these massive bespoke metal machines, basically the absolute heavy-duty picks and shovels of modern industry, how they operate, like how they make money and how they actually fit into these massive global shifts toward green hydrogen and petrochemical expansion.
Because it really is the hidden industrial backbone. I mean, you are dealing with thermodynamics, metallurgy, and fluid dynamics on a scale that is almost impossible to comprehend until you are actually standing right next to one of these colossal pieces of equipment.
Right, which most people never will. Okay, let's unpack this. Before we can begin to understand the multi-billion-dollar market they play in, we really have to establish what these machines actually are.
Yeah, what's sitting on the factory floor?
Exactly. What exactly is sitting on their factory floor right now?
Well, broadly speaking, they manufacture industrial process equipment. But to get incredibly specific, roughly 80% of their top-line revenue comes from heat exchangers.
Okay, 80%. That's massive.
It is. And primarily what is known as the shell and tube design. But beyond that, they also build high-pressure reactors, pressure vessels, distillation columns, cooling towers, and heavy-duty industrial centrifuges.
Okay, let's pause on the heat exchanger for a second, because that term, I mean, it sounds like the radiator in a Honda Civic.
Right. Sounds very mundane.
Yeah, and we need to be clear about the scale here. So explain to me what a shell and tube heat exchanger is in this specific industrial context and why it requires so much custom engineering.
So the basic physics concept is actually really simple.
Yeah.
You have two different fluids or gases in an industrial plant, and you need to transfer extreme heat from one to the other without ever letting them physically mix.
Because if they mix, bad things happen.
Right. If they mix, you ruin the chemical process, or worse, you trigger a massive explosion. So in a shell and tube design, you have this massive outer cylinder. That's the shell. And inside that shell, you have a bundle of hundreds, or sometimes thousands, of smaller metal tubes. One incredibly hot, highly pressurized chemical runs through the inner tubes, and a cooler fluid runs through the outer shell, washing over those tubes to absorb the heat.
Okay, that makes sense. It's basically like a giant metal thermos, but filled with thousands of metal straws.
Exactly. That's a great way to picture it. But the complexity, it comes from the operating conditions. Like I said before, we aren't talking about boiling water here.
Right.
We are talking about highly corrosive toxic acids at thousands of degrees under, immense pressure. So the thickness of the shell, the specific type of metal used for the tubes, the way the tubes are literally welded to the end plates, every single millimeter of that is engineered for one specific chemical process at one specific refinery.
And the physical scale of this is just wild. We are talking about equipment that ranges from 20 metric tons on the very small end all the way up to 800 metric tons.
Yeah, 800 tons it's a building.
It is. You do not just browse a catalog, point to an 800-ton heat exchanger, and, click add to cart.
Right, and that completely dictates who the buyers are. I mean, you aren't selling to wholesalers here. The direct buyers are the massive EPC firms.
EPC being...
Engineering, procurement, and construction companies.
Ah, right.
These are the mega contractors that are hired to build multi-billion-dollar plants. And the end users of this equipment, they span oil and gas, petrochemicals, liquefied natural gas, fertilizers, and even aerospace.
Wow, aerospace too. Okay, so to put some actual numbers to this operation, let's look at the data. In FY25, ANUP did 733 crore rupees in revenue.
Very solid number.
Very solid. And they operate on a firm order backlog, which stood at 568 crore rupees. And what stood out to me was that a massive 41% of that backlog is destined for export markets.
Which is a huge shift for them, yeah?
Yeah, but wait, let me push back on this business model for a second, because something isn't clicking for me.
Sure.
If every single 800-ton machine is totally custom engineered, right? How do they avoid drowning in R&D costs?
Ah, right.
I mean, in almost any other industry, if you custom design every single unit you sell from scratch, the engineering overhead just eats you alive before you even cut the first piece of steel.
It's a really great point, and I think it reveals a lot about the unit economics of heavy industry compared to, say, tech.
Right.
In this space, the engineering isn't speculative. A software company might spend millions of dollars designing an app, hoping a market exists for it, hoping people download it.
Right, hoping for product market fit.
Exactly.
Okay.
ANUP doesn't do that. The engineering and the design work, it's directly embedded into the project contract itself.
Oh, I see. So the client is essentially paying them to do the R&D for that specific machine as part of the initial purchase price.
Precisely. They are billing the complex thermal modeling, the metallurgical testing, all of it directly to the cost of goods sold for that specific individual project. And furthermore, while the external dimensions or the specific metal alloys might change from order to order, the underlying physics, the thermodynamics of heat transfer, those remain constant.
Right. The laws of physics don't change just because the refinery is in a different country.
Exactly. So they are essentially applying a deeply established, proven engineering library to a new set of dimensions. It's custom, but it's built on a 60-year foundation of proprietary knowledge.
Okay, that makes the economics much clearer. They aren't inventing a brand new concept every time. But to understand how much runway a company like this actually has, we have to zoom out. We have to look at their total addressable market, the TAM.
Right. And this TAM is driven entirely by CapEx cycles, capital expenditure.
Okay, walk us through that.
Well, when a heavy industry operator decides to build a massive new greenfield plant or, completely overhaul an existing one, that requires massive CapEx. And these heavy-duty machines have incredibly long lifespans, usually around 15 to 30 years.
So they aren't replacing these things every couple of years like a smartphone.
No, not at all. So the demand comes either during those massive new capacity expansions or during what the industry calls turnarounds.
Right, I saw that in the reports. A turnaround is essentially when a massive refinery just shuts down entirely for a few weeks of intense scheduled maintenance.
Yes, they literally tear out the old degrading heat exchangers and swap in the new ones. It's a massive, highly choreographed logistical event, hundreds of contractors swarming the site.
Wow.
And if we break down the total market across India and their export regions, the numbers are just massive. Oil and gas refining alone accounts for $2 to $4 billion annually in equipment demand.
2 to 4 billion just for refining.
Right. And petrochemicals represents another $1.5 to $3 billion. Power generation is another $1 to $2 billion. So when you roll in fertilizers and emerging spaces like hydrogen, the total addressable market for ANUP's specific equipment is estimated at $6 to $12 billion annually.
Which brings us to a data point that genuinely made me do a double take when I was reading the report.
The penetration rate.
Yes. The penetration. So ANUP's 733 crore rupees in revenue is obviously a substantial amount of money. But it represents a microscopic 0.7 to 1.5% penetration of that $12 billion market.
If we connect this to the bigger picture, it highlights a classic fragmented market dynamic. I mean, there's no single dominant monopoly in the Indian process equipment manufacturing space. The market is highly, highly fractured.
But wait, why is that? I mean, if the market is worth up to $12 billion a year, why hasn't a massive conglomerate just swept in, consolidated everyone, and taken like 50% of the market?
Because the barriers to entry are incredibly steep. And the risk of catastrophic failure is so high that buyers simply will not take a chance on an unproven newcomer, no matter how cheap their bid is.
Oh, right, because of the whole city block disappearing thing.
Exactly. First, you have the regulatory and compliance hurdles. You need ASME certification, which is basically the gold standard for boiler and pressure vessel design globally. You also need PSO and IBR compliance in India.
Okay, but the sources mentioned another detail that I really want you to explain, because honestly, it sounded absolutely absurd to an outsider.
The welding procedures.
Yes. The report said ANUP has over 1,800 qualified welding procedures across various complex metallurgies. 1,800. Look, I don't know much about manufacturing, but melting metal together isn't that complicated. A weld is a weld. Why on earth do you need 1,800 different ways to do it?
It sounds absurd until you really understand the metallurgy required for these environments. A
Oh,
weld is absolutely not just a weld.
okay, why not?
When you are joining two pieces of exotic alloy, say, a specialized chromium-molybdenum blend, you cannot just apply heat and standard filler wire. The intense heat of the welding torch physically alters the crystalline structure of the metal right at the joint.
Oh, wow.
Yeah, and if you use the wrong filler material or the wrong voltage or even the wrong cooling rate, that joint becomes extremely brittle.
And if it becomes brittle, it snaps when it's pressurized with toxic gas.
Precisely. So every specific combination of base metal, filler material, plate thickness, and operating pressure requires a distinct, mathematically modeled, and physically tested welding procedure.
So they can't just guess. They have to prove it works every single time.
Right. The company has to weld a test piece, X-ray it, stress test it until it literally breaks, and then document the exact parameters.
Mm-hmm.
And that becomes one qualified welding procedure.
One.
Just one. And ANUP has spent 60 years accumulating a library of 1,800 of those tested certified procedures.
Okay, wow. So if a brand new, well-funded competitor decides to enter this market tomorrow, they can't just buy a factory and start bidding. They have to literally invent, test, and document thousands of welding procedures from scratch.
And even if they manage to do that, it takes 2 to 3 solid years just to get placed on the approved vendor list by a major EPC firm. The EPC firm has to fly out, audit the new factory, review all the procedures, and ensure the safety culture is flawless before they will even let that new competitor bid on a single project.
That is a staggering moat. It really is. It means a company like ANUP doesn't need to invent a brand new industry to see massive revenue growth. They just need to slowly, methodically capture a tiny fraction of a percent more market share from their existing competitors.
Exactly. But, that growth does depend on macroeconomic wins.
Yeah.
They still need the overall market to be actively building and expanding.
Right. Which means we need to talk about the massive structural shifts driving this market right now. The sources make a really interesting distinction here. They split ANUP's revenue base into two categories.
Cyclical and structural.
Yes, about 60 to 70% of their revenue is cyclical, meaning it relies on the standard 4 to 7 year ebb and flow of traditional oil and gas capex. But 30 to 40% of their revenue is structural.
And that structural revenue is key, driven by long-term, policy-driven shifts that fundamentally alter the industrial landscape. They don't care about a temporary dip in the price of a barrel of crude oil. And the most significant structural shift right now is the energy transition, specifically the move to hydrogen.
This was the biggest revelation in the data for me. Hydrogen already accounts for 30% of ANUP's FY25 revenue.
Yeah, that's huge.
That is up from almost zero just a few years ago. And the Indian government has a national green hydrogen mission with a stated target of producing 5 million tons per year by 2030.
Which requires a massive build-out of infrastructure.
Exactly. But why is hydrogen so special when it comes to the equipment? Like, why can't a new hydrogen plant just buy the exact same steel tanks that an oil refinery uses?
Because of a fascinating and terrifying phenomenon called hydrogen embrittlement.
Hydrogen embrittlement. Okay, tell me about that.
So hydrogen is the smallest element in the universe. Its atoms are incredibly tiny.
Right, basic chemistry.
When hydrogen gas is placed under extreme industrial pressure and high temperatures, those tiny hydrogen atoms can literally diffuse directly into the solid steel lattice of a standard pressure vessel.
Wait, really? So they just slip right between the iron molecules and the solid steel walls?
Yes. And once they are inside the metal, they combine to form hydrogen gas molecules within the microscopic voids of the steel. And this creates intense internal pressure from inside the metal itself.
It's like microscopic sand finding its way deep into the pores of a sponge until the sponge is so packed with sand it just becomes rigid and crumbles under pressure.
That is exactly what happens. The steel loses its ductility, becomes profoundly brittle, and can catastrophically shatter without any outward warning signs. It looks fine until it just shatters.
That's terrifying.
It is.
Okay.
So to prevent this, you cannot use standard carbon steel. You have to fabricate these machines using highly advanced exotic metallurgies like Inconel or specialized chrome-molybdenum blends.
And because ANUP holds those 1,800 welding certifications, they actually know how to weld Inconel without ruining it.
Exactly. The shift to the hydrogen economy isn't just a brief capex bump for them. It is a massive, multi-decade structural tailwind that provides a heavy layer of downside protection against the volatile boom and bust cycles of traditional oil refining.
It's the difference between a wave and a rising tide. The cyclical oil markets are the daily waves you ride. Sometimes the surf is up, sometimes it's flat. But the green hydrogen transition is a rising tide that is permanently lifting the water level of the entire ocean beneath them.
I like that analogy. And that isn't the only rising tide. The data also points to petrochemical expansion as a really high-strength trend.
Right, because we need plastics.
Yeah, India's domestic consumption of plastics, synthetic rubber, and specialty chemicals is growing at a 6 to 8% compound annual growth rate. That requires a relentless, sustained domestic capex cycle.
And we also have to look at exports. The Middle East and Southeast Asia are undergoing massive industrialization right now. The Q2 FY26 data shows a full 56% of ANUP's revenue in that specific quarter came from exports.
That's a massive pivot for them.
It is. But here's the question. If an EPC firm in Dubai is building a massive new petrochem hub, why do they buy from ANUP? I mean, why not go with a massive European manufacturer or a heavily subsidized Chinese manufacturer? What is their specific competitive edge in the global market?
It really comes down to two primary factors: proprietary technology and execution track record. In terms of technology, they utilize specialized designs for their heat exchangers, specifically models called the heel exchanger and the M-baffle.
Okay, so what does a heel exchanger actually do differently than a standard shell and tube model?
So in a traditional heat exchanger, you have straight metal baffles inside the shell. These force the cooling fluid to zigzag back and forth over the tubes.
Okay.
The problem with straight right-angle zigzags is that they create dead zones in the corners. These are areas where the fluid slows down, stalls, and deposits sediment or gunk.
Which obviously ruins the thermal efficiency over time because you're basically coating the tubes in sludge.
Precisely. It acts as an insulator, which is the exact opposite of what you want. So a heel exchanger replaces those straight baffles with continuous helical-shaped baffles.
Helical, like a spiral.
Right. It forces the fluid into a smooth spiral tornado-like flow through the shell. This completely eliminates the dead zones, continuously sweeps the tubes clean, and dramatically improves the heat transfer coefficient.
Wow.
Yeah, it allows the plant owner to use a much smaller, more compact heat exchanger to achieve the exact same thermal results.
And in a massive industrial plant, space and thermal efficiency equal millions of dollars in operational savings over a 20-year lifespan. That makes total sense. Here's where it gets really interesting, though. What about the execution track record?
They boast a greater than 95% on-time delivery record, backed by over 60 years in this specific domain. And that is tied directly to their exclusive operational focus. They are a pure-play process equipment manufacturer.
Meaning they don't do anything else?
Exactly. Unlike their massive, diversified competitors, companies like L&T or Godrej and Boyce, which builds everything from consumer appliances to bridges, ANUP only does this.
And if you are the lead project manager at that EPC firm in Dubai, your entire multi-billion-dollar timeline is tightly choreographed. If one massive heat exchanger is delayed by 3 months at the factory, you can't just skip that step and build the rest of the refinery.
No, it literally stalls the entire project.
You are bleeding millions of dollars a day in idle labor costs. So in that scenario, you are absolutely not sorting your vendor bids by price low to high. You are shopping specifically for that 95% on-time delivery metric. Certainty is the actual product they are selling.
And that certainty commands a premium, which is why ANUP historically maintains EBITDA margins over 20 to 22%, which is fantastic. They vastly outperform their diversified peers who often suffer from margin dilution across their, less profitable divisions.
Right. High margins and reliable delivery are fantastic on a corporate brochure, but we really need to look under the hood at the financial engine. How does this actually translate to the balance sheet?
The unit economics here are defined by massive operating leverage. Let's look at their cost profile. ANUP carries roughly 90 crore rupees in fixed costs.
And that covers?
That covers the depreciation on their 170,000 square meter manufacturing facilities, their core engineering teams, and standard administrative overhead.
Okay, 90 crore fixed.
Right. Now, on the variable side, which includes the raw steel, the Inconel alloys, and the direct project, that makes up about 65% of their revenue.
So if I understand the math on that fixed versus variable structure, it means that for every 1% in revenue growth they generate above that baseline fixed cost, it translates to roughly 1.4% in EBITDA growth.
Because the fixed costs don't scale up with the revenue.
Right, because once the factory roof, the lights, and the engineers are paid for, every additional 800-ton machine that rolls out the door drops a significantly larger portion of its revenue straight to the bottom line.
That is the beauty of operating leverage in heavy manufacturing. But an equally critical component is how they manage their working capital. They operate heavily on customer advances and progress billing.
Explain how that works in practice, because this isn't like selling a car where the buyer gets a loan and hands you a check on day one.
Right, it's very different. When ANUP signs a contract to build a 50 crore rupee high-pressure reactor that will take, say, 14 months to engineer and build, the customer pays a significant advance upfront.
Before any steel is even cut.
Exactly. And then as ANUP hits specific milestones, like completing the thermal engineering, receiving the raw Inconel at the factory, completing the welding of the shell, the customer makes progress payments along the way.
So ANUP is effectively using the customer's own money to fund the purchase of the raw materials and the labor for that specific machine. They aren't going to a bank and taking out massive high-interest loans to finance the construction.
Exactly. And the data shows this efficiency really clearly. Their working capital turns improved to 3.6x in FY25, and they maintain a cash conversion cycle of roughly 90 to 120 days. It is an incredibly capital-efficient model.
So we have a highly efficient cash-generating engine that essentially funds itself via customer advances. With that engine humming, management has set an aggressive target reaching 1,000 crore rupees in sales by FY27. That is a massive leap from 733 crore. Where is that new growth actually coming from?
The primary vector, and the absolute most critical factor for this company, is capacity expansion. ANUP's historical bottleneck has never really been a lack of market demand. It has been the sheer physical limitation of their factory floor.
They just didn't have the space.
Right. They simply could not push enough steel through the facility fast enough. To solve this, they are aggressively expanding their CADA plant, specifically Phase 2B of the facility. The analysis indicates that this expanded CADA facility alone has the potential to generate 450 crore rupees in revenue.
That is the cork being popped out of the bottle. If the factory floor is the constraint, building a massive new factory floor solves it.
The second vector is entering new, highly lucrative sectors, specifically nuclear energy. They recently secured their very first order from a major EPC company operating in the nuclear sector.
And if we thought petrochemical plants had high standards, nuclear is entirely different. It is a true zero margin for error industry. Winning a fabrication order for nuclear power infrastructure is the ultimate validation of their clean rooms and their 1800 welding certifications.
Exactly, it's a massive flex for them. And the third vector is simply market catch-up. Analyst forecasts show ANUP's revenue historically growing at 10.3%, while the broader Indian capital goods market is growing at 11.3%.
So they are lagging a bit.
Yeah, they actually need to win market share just to catch up to the broader industry. But with the current inquiry pipeline sitting at a massive 1,100 crore rupees, the demand is obviously there to support that catch-up.
Okay, if we stop the analysis right here, it paints a flawless, almost inevitable picture. Massive global demand for hydrogen, a brand new factory unlocking 450 crore rupees in capacity, a massive inquiry pipeline, and a highly efficient financial engine.
It looks perfect.
But this is heavy industry. We exist in the physical world, not on a spreadsheet. And looking at the most recent data, things have taken a sharp, painful turn. We need to talk about the risks and what the analysis calls the Q3 shock.
This raises an important question. Because yes, the financials present a very stark, very immediate reality check right now. The company is currently experiencing a severe margin squeeze.
Walk us through the numbers.
So despite achieving impressive 29% year-over-year revenue growth in FY25, hitting 708.27 crore rupees, their net profit earnings per share plummeted. It fell from 103.99 down to 58.35.
Ouch. So they pushed significantly more equipment out the door, but made drastically less profit on each unit.
And it gets significantly worse when we look at the most recent quarter. In Q3 of FY25-26, revenue dropped 17.22% quarter over quarter, and profit dropped 22.83% quarter over quarter. Their net margins have collapsed down to 13.6%.
That is a massive drop from the 20 to 22% historical average we praised earlier. What broke?
Two massive, highly tangible physical world problems. First is severe raw material cost inflation, specifically massive unexpected surges in global steel prices.
Let's walk through the mechanics of how that destroys margins. If I am ANUP and I sign a contract with an EPC firm today to deliver a heat exchanger in 18 months, we lock in a price. 6 months later, I go to buy the 800 tons of specialized steel, and the global price of steel has spiked 30%. What happens?
Well, unless your contract has a very robust, very specific price escalation clause tied to global commodities, which many don't, you eat that 30% increase. The EPC firm isn't going to voluntarily pay more. You have to buy the steel to fulfill the contract, and that 30% premium comes directly out of your gross margin.
And the second major cause of the margin collapse is actually a byproduct of their biggest success, right? The shift to hydrogen.
Exactly. It's a product mix issue. We discussed how hydrogen requires exotic, highly expensive metallurgies like inconel to prevent hydrogen embrittlement. Currently, the raw material costs for these advanced alloys are so elevated that they are severely compressing gross margins.
Oh, I see.
So the 30% of the revenue coming from hydrogen is fantastic for their long-term viability, but right now, the material costs are deeply eroding their profitability.
And then there is the sheer physical nightmare of global logistics. You can't just put an 800-ton reactor on a FedEx plane. The sources note a specific scenario where 150 crore rupees worth of their finished custom-engineered equipment was physically stuck in transit. It couldn't be delivered due to a combination of global shipping availability issues and complex international tariffs.
And we have to connect that back to their working capital cycle.
Right.
We praised their progress billing model earlier, but the final, most lucrative milestone payment from the customer only triggers upon final delivery and installation. If you have 150 crore rupees of equipment sitting on a dock or anchored off a port due to a strike, you cannot collect that final payment.
Your cash is literally trapped inside a giant steel tube sitting in the ocean.
Exactly. Management had previously guided the market that they would quickly return to 24 to 25% margins. But the physical reality of global supply chains and commodity prices is showing severe, sustained margin compression.
Which brings up the most critical variable in any business navigating a crisis, the people at the helm. Who is actually making the capital allocation decisions during this margin squeeze?
The company is backed by the Lalbhai Group. Sanjay S. Lalbhai is the chairman, and he also chairs Arvind Ltd., a major conglomerate. But the most vital piece of data regarding the management is the ownership structure. The promoters, the founding group, hold a massive 94.81% stake in the company.
94.81%. That means the public float is incredibly small. The people making the decisions own almost the entire company. How does that practically impact their day-to-day strategy?
It creates a deeply conservative, long-term approach to capital allocation. Because they don't have to constantly appease activist hedge funds or institutional investors demanding short-term quarterly profit bumps, they focus entirely on long-term industrial capability.
We see that vividly in how they spend their cash. They are taking their profits and reinvesting them heavily into the physical, organic footprint of the business, like the 275 crore rupee expansion of the Kedah plant. They're not doing massive stock buybacks to artificially inflate the share price. They're not paying out massive special dividends to themselves. And they aren't going on a reckless M&A spree, buying up random smaller companies just to make their top-line revenue look bigger. They're strictly building more capacity to build more machines.
The operational scaling is being led by CEO Reginaldo Dusa, who has been specifically tasked with driving the export push, including opening their new strategic office in Dubai to capture that Middle Eastern petrochem demand. However, the data does highlight a significant potential point of friction regarding the broader management team.
Right. They have a deep bench of specialized roles, a chief quality officer, a VP of sustainability, but the average tenure of the current management team is only 1.4 years.
And that is a legitimate execution risk. You have the institutional knowledge housed within the 60-year history of the company and the long-term promoters providing the capital stability. But the day-to-day execution navigating unprecedented raw material volatility, scaling up a massive new factory and entering the zero margin for error nuclear sector, that all relies on a relatively new leadership team that hasn't been in the trenches together for very long.
Okay, let's pull all of these threads together. If we look at ANU Key from a macro perspective, it is a fascinating, almost contradictory business. On one hand, they are a relatively small, highly specialized operation in India, yet they hold the physical keys to multi-billion-dollar global shifts. The green hydrogen economy cannot exist, and global petrochemical production cannot expand without the highly bespoke, insanely complex equipment they manufacture. They possess a massive competitive moat built on 1,800 certified welding procedures and a 60-year track record of not blowing up refineries.
But, on the other hand, they are currently locked in a brutal, very earthly battle with the physical realities of heavy industry. They are fighting severe steel price inflation, highly complex global shipping logistics, and a painful margin compression driven by the very exotic materials required for their future growth. They have the massive inquiry pipeline, and they are building the physical capacity. But they have to prove they can actively navigate the economics of the raw materials to translate that revenue into actual profit.
So next time you are reading a news headline about a massive $5 billion green hydrogen initiative being signed into law or a new petrochemical hub opening, remember that none of it is real until someone manually, painstakingly custom welds 800 tons of Inconel into a pressure vessel that can withstand the impossible.
And that leaves us with a final, somewhat unsettling thought to mull over. If the entire global energy transition requires thousands of these highly bespoke, perfectly engineered metal behemoths, wait, sorry, let me rephrase that. If the transition requires thousands of these behemoths, and if building them requires a highly specialized, intensely trained workforce mastering thousands of distinct welding procedures, what happens if the ultimate limiting factor to global green energy isn't a lack of government funding or a lack of political will, but simply a fundamental shortage of the master welders and thermal engineers capable of actually building the physical infrastructure?
That is a brilliant and terrifying bottleneck to consider. The future of global energy might just hinge on the availability of someone who knows exactly how to weld a specific chromium alloy. Thank you so much for joining us on this deep dive.